we have seen that the Earth's surface is dynamic in nature and how the endogenetic factors like earthquakes, volcanoes are responsible for shaping the Earth's surface. Besides the endogenetic factors, the surface of the Earth is undergoing slow and continuous but invisible changes brought about by external factors, which are called as exogenetic factors. One such external factor which brings changes on the Earth's surface is weathering. In the earlier chapter, we have discussed about the rocks. Different landforms on the surface of the Earth like mountains, plateaus are made up of rocks. Weathering as a denudation process is responsible for lowering the height of the landforms. In weathering process, the role of weather or climatic elements like rainfall, temperature is important in breaking and decomposition of the rocks. In this chapter, we will try to understand the role of weathering as a denudational process, then factors controlling weathering and types of weathering. Weathering is defined as the process of disintegration and decomposition of the rocks in situ by weather and other related factors. According to Arthur Holmes, weathering is the total effect of various subaerial processes that operate in bringing about the decay and decomposition of the rocks, provided that no large-scale transport of the loosened products is involved. Weathering refers to the breakdown and disintegration and the decomposition of the rocks through mechanical and chemical changes in the rocks and their minerals affected by rainfall or water, temperature, various atmospheric gases and biological factors, etc. Insolation, rainwater, frost, atmospheric gases and organisms are considered as chief agents of weathering. Weathering is the breakdown and alteration of rocks and minerals at or near the Earth's surface. Weathering is the first step for a number of other geomorphic and biochemical processes. The product of weathering are major source of sediments for erosion and deposition. Soil formation is the end product of weathering. Weathering contributes to the formation of soil by providing mineral particles in the form of sand, silt, clay. Without soil, the earth would be devoid of plants and animal life. Weathering produces soil on which agriculture depends. The intensity and type of weathering differs from one place to another place and from one region to another. Disintegration of rock is more common in hot and dry climates, whereas chemical decomposition is more prevalent in humid climate. The weathering of rock is influenced by a number of variables such as mineralogical composition of the rock and the climate in which weathering occurs. The type and rate of weathering is generally influenced by factors like 1. Rock structure, 2. Climatic variation, 3. Topography, 4. Vegetation. Now, let us discuss about the rock structure. Rock structure includes mineral composition and physical properties of the rocks such as joints, faults, fractures, hardness, texture, bedding planes, etc. The mineral forming the rocks determine whether the rock is more susceptible to chemical or physical weathering. For example, carbonate rocks such as calcium carbonate and magnesium carbonate having more soluble minerals are easily affected by chemical weathering. Some minerals such as quartz are very stable and remain unaltered for a long time, whereas olivine is very unstable and begin to decompose almost immediately. The texture of the rock is also a significant factor affecting weathering because of its influence on porosity and permeability. Porosity and permeability influence the ease with which water can enter the rock and the mineral grains. A well-jointed rocks are more subjected to mechanical disintegration. The rocks having horizontal beds are more compact and are less affected by the mechanism of disintegration and decomposition. Factors having vertical rock strata are easily loosened and break down due to temperature changes, water and wind action. The rate of weathering is related to the nature of the rocks. Harder rocks get weathered at a lower rate than the weaker or softer rocks. A rock resistance to one type of weathering may be most susceptible to another agent. Limestone and granite provide the fine examples in this regard. Limestone is very resistant to wind, but it is highly susceptible to rainwater. On the other hand, granite is quite resistant to the action of water, but can be weathered and eroded easily in dry climate. Climatic variations. Climate is one of the most important factors of all type of weathering. Climate determines whether physical or chemical weathering will predominate in a particular area. Climate not only determines the type of weathering but also the rate of weathering. Chemical weathering is more common in humid tropical areas because of more rainfall and high temperature. Leaching process and the solution of rocks are more effective in humid tropics. Mechanical weathering leading to the disintegration of the rock is more dominant in the tropical and semi-arid regions. The rocks in the dry temperate climates are more susceptible to mechanical weathering than chemical weathering because of the alternate expansion and contraction of cracks and joints in the rocks. Rocks are least affected by mechanical disintegration in cold climate, but chemical decomposition of the rocks may be effective provided the ground is not covered for a longer duration. Seasonal variations in the climate of a region generate different conditions for weathering. For example, in monsoon climate, rocks are subject to mechanical disintegration during hot and dry summer, whereas chemical weathering is more dominant during rainy months. Topography. Among the topographic factors, slope of an area controls the rate and intensity of mechanical weathering. Slope controls mechanical disintegration of the rocks and the mass movement of the weathered material down the slope. In a region characterized by steep hill slope, rocks are easily disintegrated due to the mechanical weathering. The weathered material moves down the hill slope in the form of rock fall, debris fall, etc. Removal of the weathered material allows continuous exposure of the rock to the atmospheric condition for further weathering. The topography characterized by gentle and moderate slope is less affected by mechanical disintegration. Vegetation. Natural vegetation controls the rate and type of weathering. The nature of weathering is largely determined by the presence or absence of vegetative cover in a particular region. Vegetative cover can partly a factor of weathering and partly a protector of rock from weathering. Vegetative cover binds the rock through their network of roots and thus protects them from weathering and erosion. At the same time, penetration of the roots weakens the rocks by breaking them into several blocks. Vegetation protects the surface from the direct impact of the sun rays. The microorganisms associated with the roots of the plant and trees helps in the decomposition of the rocks through biochemical weathering. Based on the nature of changes in the rock and weathering agents, there are three main types of weathering: physical or mechanical weathering, chemical weathering, and biological or organic weathering. Physical weathering is defined as the disintegration of the rocks due to temperature variation, frost action, wind action, and pressure release. The rock is broken and disintegrated without any chemical changes in the rock. In physical weathering, the physical state of the rock changes. That is, a bigger rock is broken into smaller and smaller pieces, and so on. The physical weathering agents are frost, temperature, and wind. The processes that may cause physical weathering are aberration, crystallization, insolation or temperature, slacking, pressure release, freezing and thawing or spalling, etc. Aberration. Aberration occurs when two rock surfaces come together, causing mechanical wearing or grinding of their surfaces. Collision between the rocks surfaces occurs during the transport of the eroded material by water, by wind, and glacier. Crystallization causes necessary stresses needed for the mechanical rupturing of the rocks and minerals. Crystal growth causes stress due to the elements change of physical state with change in temperature. The transformation from liquid to solid crystalline form produces volumetric change, which in turn causes necessary mechanical action for rupture. Upon freezing, the volumetric change of the water from liquid to solid is 9%. The crystallization of the salt exhibits volumetric changes from 1 to 5%, depending upon the mineral content and temperature of the rock. Insolation or temperature. Rock is not a good conductor of heat. The inability of the rock to conduct the heat results in the differential rate of heating and resultant differential rate of expansion and contraction. The surface of the rock expands more than its interior, generating stress within the rock. This stress is the cause for the rock to rupture or disintegrate. Differential expansion and contraction also depends on the mineral composition. If the rock is heterogeneous in mineralogical composition, their coefficient of contraction and expansion due to temperature variation varies, due to which stress develops within the rock. Dark color grains or mineral particles, because of their heat absorptive properties, will expand more than the light color grains. Alternating wetting and drying of the rock or slacking is one of the major factors in the weathering process. Slacking occurs by the mechanism of ordered water, which is the accumulation of successive layers of water molecules in between mineral grains of the rock. The increasing thickness of the water pulls the grain apart with a great tensional stress. Pressure release of rock can cause physical weathering due to the unloading of superincumbent load or release of pressure helps in the weathering process. For example, igneous rock below the earth's surface are at much higher temperature and pressure. When the erosion brings these rocks formation to the surface, they are subjected to less pressure. The unloading of the pressure causes the rock to fracture horizontally, developing fractures in the rock. Physical weathering based on the processes of disintegration of the rock is divided into various types as 1. Exfoliation, 2. Spheroidal weathering, 3. Block disintegration, 4. Granular disintegration, 5. Frost wedging, and 6. Salt crystal wedging. Exfoliation. Exfoliation refers to a type of physical weathering in which the outer layer of the rock is peeled off in the form of concentric layers. The outer shell of the rocks becomes loose due to alternate expansion and contraction due to high temperature in the day and low temperature in the night. The loosened outer layer of the rock is peeled off or removed. Differential heating of outer and the lower layer or shells of a rock mass causes flaking. Solar radiation penetrates up to few centimeters in rocks due to low thermal conductivity. Thus, the outer layer of such rocks expands more than the layer of rock lying below. The differential expansion of rock layers or shells causes flaking, due to which thin outer layer of the rock is detached from the rock mass. Thus, the rock is disintegrated in the form of layers after layers. This type of weathering is also called as onion weathering. Exfoliation is mostly seen in hot, arid and semi-arid climate. Exfoliation is very common in massive crystalline rocks, that is more pronounced in granitic rocks. Many of the granitic batholiths which are exposed above the ground surface are being continuously subjected to the exfoliation type of physical weathering. Example, exfoliation dome near Bhongir town in Telangana, Khanke dome near Ranchi city. Spheroidal weathering and its effects are similar to exfoliation. The outer layer or the shell of the rock is affected by the penetration of water and chemical reaction, cause the outer layer to swell and expand and peeled away from the remaining rock mass. Spheroidal weathering is common in humid climate, whereas exfoliation is seen in the hot, arid climate. Block disintegration. Block disintegration is caused mostly by temperature variation. Due to temperature variations in the day and night, the rock expands in the daytime and due to relatively high temperature shrinks during the night time under low temperature. Block disintegration is common in the rocks with well-jointed structure. The joints of the rocks will act as zone of weakness because weathering agents are more active along the joint planes of the rock. The rocks are disintegrated along the joints. The expansion and contraction of the rock, especially along the joint plane, leads to block disintegration. The rocks disintegrated along the joints and blocks and broken in the form of large blocks of rocks are dislodged along the joint plane from the main rock. This phenomena is common in desert areas. Block disintegration is also a result of unloading of superincumbent roll or release of pressure. Granular disintegration. Granular disintegration is seen mostly in rocks with heterogeneous mineralogical composition or coarse grained rocks, or the rocks which has variety of minerals. If the rocks are coarse grained or of different color or mineralogical content, they absorb the insolation differently. Thus, the rock mass absorbs insolation differentially and gets heated at a differential rate. Different parts of the rock or different minerals are affected by differential expansion and contraction, which causes stress within the rock, due to which they are disintegrated into smaller particles. The rocks develop cracks and the surface spalling. The highly heated rocks, when struck by sudden rainfall, develops numerous cracks. The repetition of mechanism causes spalling and granular disintegration of the rock. Frost wedging. Frost wedging is common occurrence in the temperate and cold climate. This process is more active in areas which are often characterized by alternate process of thawing and freezing of water in the day and night. Frost action weakens the rock in two ways: due to freeze and thaw of water between the particles of the rock, and due to the freeze and thaw of water in the crevices and pore spaces of the rock. Highly consolidated rock like granite is least affected by frost action. The less compact and loosely consolidated rocks most affected by frost action. Sedimentary rocks, being more porous, are highly susceptible to the process of weathering. Water present between the particles of the porous rocks freezes during the night due to the fall in the temperature below the freezing point, and thus expands due to the increase in its volume by about 10%. In the daytime, when the temperature of the water reaches above the freezing point, thawing of water takes place. This diurnal or daily cycle of freezing and thawing causes alternate expansion and contraction, which introduce tension and stresses that is subsequently builds up in the rock, due to which the rocks are disintegrated into smaller blocks of pieces. This is very slow process and takes relatively longer time for the rock to get disintegrated. In the high latitude and high altitudes with very low temperature, alternate expansion and contraction of crevices, pores, cracks in the rock occurs due to diurnal freezing and thawing. It causes block disintegration of the rocks, wherein rocks are broken into large blocks which are dislodged from the main rock mass along the joints or crevices. When this type of weathering operates over the hill slopes of well-jointed massive rocks, the dislodged rocks fall or rolls down or tumble down the slope in the form of rock slides and gets collected at the base of the hill slope. The disintegration of the rocks due to diurnal freezing and thaw cycles in the glacial and periglacial areas is called as frost wedging or congelifraction. Salt crystal wedging. Growth of salt crystals in the rock pores is also an important process of weathering. The process operates extensively in dry climates. During the long drought periods, groundwater is drawn to the surface of the rock through the capillary action. As the evaporation takes place, tiny particles of salt such as halite, that is sodium chloride, calcite, that is calcium carbonate, gypsum, that is calcium sulfate, are left behind and deposited in the rock pores and crevices. The growth of these crystals produces grain by grain disintegration of the rock. Salts in the rock, when subjected to thermal action, hydration and crystallization, certain salts in the rock like calcium, sodium, magnesium, potassium and barium have a tendency to expand. In hot desert areas, the salt expansion or the crystals cause splitting of individual grains within the rocks, which eventually falls off. This process of falling of individual grains may result in granular disintegration. Weathering is an exogenetic process. Weathering is the disintegration and the decomposition of the rock. The factors controlling the type and rate of weathering are climate, vegetation, rock structure, slope, etc. In physical or mechanical weathering, disintegration of the rocks takes place without any chemical or mineralogical changes in the rock. Physical weathering operates both in hot and cold climate. The major controlling factor in physical weathering is mostly temperature. In the next session, we will be discussing the other two types of weathering like chemical and biological weathering.